Hey guys, this is Mr. Galoy again. Hey, today in this movie, I'd like to talk to you a little bit about conversions. Doing conversions is something that we kind of need to do in science, especially in some problems in physics also. Before we maybe get started on some practice problems, we really have kind of two ways of measuring things in this world. We got, at least in our country, we've got our system, the American system. For example, we talk about inches, we talk about a foot, we talk about gallons if we're dealing with volume, we talk about miles, but most other countries use the metric system, and so instead of an inch, we might talk about, so many centimeters, for example, or so many meters. Or if we're dealing with like miles in our system, we might talk about kilometers in the metric system. Again, the metric system really is much easier to deal with because it uses common prefixes, deci, milli, kilo, for example. It's also, based on units of 10, and that makes things a little bit easier. Well, because we do live in our country, in the U.S., we kind of have to be able to convert from our units to the metric system and the metric system back to our units, and we need to be able to do some of this stuff. And I know you probably remember things like the fence and rail from chemistry, and that's perfectly great, a great way of doing things, and if you've got to want to kind of do it that way, that's fine too, not a problem. What I want you to kind of have in front of you is this kind of document. This is kind of a document I got out of a textbook, and it's got a lot of different conversions on here, and we have conversions of length and of speed. This is kind of a good one for physics, this document, because it's got kind of most of what we need on it, and on the back side, we have some temperature conversions, etc. So let's take a look maybe at kind of length here. So what we have here under length, we've got a kilometer here, and we've got a lot of things that it's equals to. So these represent really conversions. We have the left side equaling to the right side. So 1 kilometer is the same as 1,000 meters. 1 kilometer is the same as 3,281 feet. 1 kilometer is the same as 0.62 miles. We've got then a bunch of other sorts of length conversions. We also have area conversions. This area right here is speed, and that's a real common physics idea, and we'll be using some of these conversions. Well, let's maybe do a couple of practice problems. What you see on the screen here, this is Mount Everest, and just for my research I found that Mount Everest is around 29,000 feet high, or in altitude. So let's say we want to take Mount Everest, that height in feet, and we want to convert it maybe to miles. We can do that. So it says here that 1 mile is the same as 5,280 feet. So we can come back to our sheet of paper. Again, you'll need a calculator kind of out in front of you also. But so we kind of start with what we know. We know then Mount Everest is around 29,000 feet. Now we always want to write the number, and then we want to write the unit here too. Now I'm going to go ahead and use fence and rail because you might be kind of familiar with that, and we kind of make this little box here, this little T here, whatever, fence I guess if you want to call it that. And we just said that 1 mile from this appendix, we said that 1 mile really is the same as 5,280 feet. So we want to put 1 mile on the numerator, and we want to put this 5,280 feet on the denominator, and that's going to allow my units, feet and feet, to cancel here, and that's going to leave me with an answer of miles. That's in the numerator. So to make this calculation, all you'd have to do on your calculator is take your 29,000 and divide it by 5,280. When I do this on my calculator, I get, about 5.5 miles. So we can say then that Mount Everest is 29,000 feet approximately, or it's about 5.5 miles. We've just converted. Now we may want to then put this maybe into the metric system. So we could say, well, we know here from this Appendix A that 1 kilometer is the same as 0.62 miles. So we can take our 5.5 miles, again we can use fence and rail if we want to, and we know there's 0.62 miles then in 1 kilometer. So we'd want the 0.62 miles in the denominator, and that's equivalent then to 1 kilometer. Again, you can use symbols here, but you want to make sure and include your units here. The miles cancel, and all we have to do then is take your 5.5, multiply it by 1, divide it by 0.6. When I do that on a calculator, I get about 8.87 kilometers. And that would be the conversion. So Mount Everest, 29,000 feet, 5.5 miles, or around 8.87 kilometers. Let's maybe do another example involving speed, since that's pretty common in physics. You know, in this country, speeds are often measured in miles per hour. So, you know, if you're driving on K10, you know, maybe you're going 70 then miles per hour, and that's kind of how you write that. 70 miles per hour, you know, symbolizes mph if you see a speed limit sign. And let's say you wanted the equivalent speed in Europe. Well, in Europe they don't use miles per hour, they use kilometers per hour. So again, we'd want to do our little fence and rail here, and we'd have to look up the conversion here. It says that 1 mile per hour is the same as 1.61 kilometers per hour. So 1.61 kilometers per hour is the same as 1 mile per hour. Again, the miles per hour units cancel. In this case, we want to multiply 70 times your 1.61 and divide it by 1. So we take our 70 times 1.61 on my calculator, and I get about 113 or so kilometers per hour. Boy, you're going fast. Well, not really. It's the same speed, guys. So this is in 70 miles per hour is equivalent to 113 kilometers per hour. Same speed, just a different unit of measure. That's what conversions will kind of do for you. We'll be able to go from one to the other. You know, sometimes we have to use a much wider or broader fence and rail to do some problems. Many of these problems that we deal with conversions deal kind of with time, and kind of the preferred unit of time in physics is the second. But often we want to kind of deal in the hour, or maybe we want to talk about years, for example. And so we often need to convert time in some way. So maybe I ask you to say, well, how many seconds might there kind of be in 1 week? So, you know, how many seconds in 1 week? So that's kind of our question here. So again, we're dealing with the week here, 1 week, so we're going to start with that, 1 week. And again, if we want to use fence and rail, we kind of can do that. Well, 1 week is 7 days, so we'd write 1 week. That goes in the denominator. 7 days go in the numerator. And in this case, we're not to the second yet, but we're getting smaller in time, so I want to maybe put another section of that here. And so we've got 1 day is 24 hours. All right, so then we can say 1 hour is 60 minutes. And then we could kind of say, you know, 1 minute is the same as 60 seconds. So, see, this was quite a bit here on the fence and rail, but that's not super uncommon in some of our are stuff that we do to have quite a chain here. So in this case, we're going to multiply all the numerators and divide all the denominators. Let's check your units first though. Weeks cancel, days cancel, hours cancel, minutes cancel, and look what we're left with, seconds. And that's exactly what we want. How many seconds? So we're going to take 7 times 24 times 60 and then times 60 again. Well, that's a pretty big number. Kind of when I do it on the calculator, I get what, 604,800. I'm kind of running out of room here. 604,800 seconds. So 1 week is equivalent to this many seconds. So there's some practice conversions. I'm gonna have you guys do some of these just for practice. Again, this is kind of important in physics, that you're able to go from one sort of unit to another unit. And again, this is called in doing conversions. Bye now.